Okay, so in order to, Mr. Rops here, we're going to solve this equation here. And we're going to do this all algebraically because this is not a graphical or a GDC problem. So if I look at A part, the key to solving the quadratic equation is I want one side to equal 0. And so in order to do that, I'm going to get x squared, subtract x, subtract 12 will be 0. And then I'm going to want to factor. It's quite straightforward. I ask myself, what two numbers multiply to get negative 12? So multiplying for negative 12, and they add to get negative 1. And so if you think about that, I know it's going to be 4 and 3 get 12. And I want the negative to be on the 4 and the positive 3, which means x equals 4 and x equals minus 3, which is pretty straightforward, and I'm hoping that's easy for you guys to be able to do. Now B part is almost the same question, but we have this inequality sign here. And when I think about inequalities, I could have a sign like this or a sign like this. I know of these two signs, one of them could look like the capital L in our regular language L. And that's this one. So this one is less than. That is how I remember it. I need to be able to read this from right to left. And so this says x squared less than or equal to x plus 12. And so what I'm going to do is I'm actually going to treat this like an equal sign, and I'm going to actually pretend it is equal. So I'm going to subtract the x, subtract the 12, and I have less than or equal to 0. And again, I'm going to factor x minus 4 and x plus 3 less than or equal to 0. Now here's where it changes. If I think about my line, I know that one of my solutions was negative 3, x equaled negative 3, and the x equal to 4. So here's my negative 3, here's my 4. And what I'm going to do is I'm going to choose a number in this region here, less than negative 3. So if I choose a number in that region, negative 3, let's just pretend we're going to choose x equals negative 10. If I would plug negative 10 into this factor, I would get negative 14, which is a negative value. If I would plug negative 10 into here, that would also be negative 7, which is a negative value. And I'm not actually concerned about the quantity of this. I'm just concerned if it's positive or negative. But I know when I multiply a negative value times a negative value, together it becomes a positive. So that means everything on this particular interval, negative 3 and less, is always going to end up being a positive because it ends up being a negative value from this factor and a negative value from this factor, which will be positive. Then I go to the next particular interval. I'm going to look at the interval between negative 3 and 4. I'm going to choose a number, and I know a good number is 0. When I substitute 0 in for x, that will be 0 minus 4, which is a negative value. When I plug 0 in for this x, that's 0 plus 3, that is a positive value. When I multiply a negative and a positive, I get a negative. That means everything in between negative 3 and 4 is negative. And then finally, I do it for the last interval. I do it for the third value. I'm going to pick x equal to 7. Anything to the right of 4. If I go 7, if I plug that 7 minus 4 as a positive, 7 plus 3 is a positive 10. Those are two positive values, so they multiply to get positive. And so it's always positive here. And so I know that those ends are positive, and this middle part here in the middle is negative, always negative values. And so when I read this equation, when is x squared minus x minus 12 less than or equal to 0? Less than or equal to 0, that there, this means negative. And so it's going to be negative 3 less than x less than 4. because there's an equal to sign, it could be negative 3, and it could also be 4. And so every single x value between negative 3 and 4 will make this function, or inequality, x squared, will always be less than or equal to x. Now the last part I want to talk about is this graph here. The question was x squared less than or equal to x plus 12. If I graph the two graphs, and you can see clearly that the red graph here is x squared, and the blue line here is x plus 12. This equation is saying, when is x squared less than x plus 12? Well, less than implies below. So here is where the x squared graph is below the blue graph. And you can see that that's at negative 3 to 4. And so again, between 3 and 4. The other way I'd consider it, if I do x squared minus x minus 12 is less than or equal to 0, and if I graph this scenario here, and if I graph this, that is, if I look at the calculator, I've actually done it on the calculator. I've graphed x squared minus x minus 12. And I know those points here are negative 3 and 4. And so I want to know, when is the graph less than or equal to 0, meaning below the x-axis. So in this region down here, so if I do it here, specifically all these values here are when x is below the x-axis. So this is going to be negative 3 to 4. And so again, I know it's negative 3 less than x less than 4. And so whether we look at it graphically of a quadratic below the x-axis, or if we look at it two lines and one is one line below the other line, or if we do it purely algebraically, we can solve these